Hi, welcome. We'll wrap up our discussion on how to find determinants of 3x3 and 4x4 matrices. What I have here is a pre-made slide that shows you from this 3x3 matrix that there are many ways that you could find the determinant by using any row or any column. Like, for example, the entries 2, -1, and 8, opposite of -1 because it's in that first row, second column, which is an odd sum. You can see the determinants of the minor that's left. Or -5, -3, and -7, which comes from this. The -5 from this entry, leaving the -3 and switching this to a -7 with the minors that are corresponding, or even choosing a column and doing the same thing with the cofactor and matrix, the determinant of the cofactor matrix, like 8, the opposite of 7, and -5. You can literally choose any row or any column and complete this process. Once again, I'm just showing you another example of how you could see it from any row with the notation for why it would be odd or even, which makes the values positive or negative. What I'd like you to do is think about, from this 4x4 matrix, which column or which row would you use in order to find the determinant? I'll stop my slides. So there's literally 8 different ways you could do it, but I chose the first column. You could go a different direction if you'd like, but I chose this 2, 0, -1, and 0, and you can see the corresponding minor. Now in this case I just put 0 and didn't show the other work for this and this 0, but I could have shown the minors that all would be multiplied times 0. So now you need to continue the process and figure out, so then what's the determinant of this matrix and the determinant of that matrix? And you almost have the exact same thing all over again. So in order to do that, I can choose any row or any column. Just to give you a heads up before I pause it, I'm going to choose the third column and the first row. Alright, so now I have some of my work shown. If I'm taking this third column here, I take the original 2 times 3, and it stays positive because of the even number of rows and columns added together. And I need the determinant of this minor, 2, -3, 2, 2. I have a 0 and a 0. If I continue this column, I didn't show all of the minor or the determinant of that minor. I also have a bunch of zeros from before and -1, and I'm following this column. -1 times 0 times this minor, which is insignificant because it's a 0. -1 times -2, because this is in that odd sum row column, and the determinant of this minor, -1 times this 2, and the determinant of this minor. I'll pause and we'll come back to the answers in just a second. And now at this point it's really just arithmetic, that the determinant of this is +2, multiplied together gives me 12, a bunch of zeros. This gate multiplies to gives me 2. The determinant of this matrix is a +10. -2 times the determinant of this minor, which gave me 17. Do some arithmetic, and then you end up with your determinant of this matrix, a 4x4, is -2. I wanted you to see that a triangular matrix has a unique characteristic. So in this case, notice that it's an upper triangular matrix with zeros below the main diagonal. If I were to choose a row that's or the column that's the easiest, I would probably either pick the first column or the third row, and it really doesn't matter. So I'm just going to pick the first column. If I was doing that, I'd have 2 times the determinant of this minor, which is -1, 2, 0, and 3. Then I'd have a bunch of zeros from this entry in the column and this entry in the column. Notice that when I find the determinant of this minor, it really is just 2 times -1 times 3, because it's AD minus BC. What I'm going to get from that is just basically subtracting nothing from this. And I have all the other zeros that still kind of play along. So notice that to get the answer, it's really just 2 times this main diagonal, which gives me a final answer of -6. And this will work for every triangular matrix, that in order to find the determinant of it, you really, you could show all of your steps, but basically it will always just be the entries on the main diagonal multiplied together. I'm not going to do all of the work for this, just going to kind of leave it, but when you see that you have to find a determinant of a 4x4 matrix by hand, you're looking for the most zeros that are possible. In this case, I'm looking at the third column and taking those entries, thinking about when it's positive or negative, and continuing to find the determinants of the cofactors of the minor. Thank you for listening, and I hope that these videos help you for your assignment to come.